Well, it's currently 5 minutes before 10 o'clock on Saturday, the 10th of August. Tonight, I do have kind of a plan, and that plan is optimizing for image quality in terms of aesthetics rather than depth of reach. Last night's real-time imaging revealed that there really isn't that much to be sacrificed by reducing the brightness of the screen, but there's a whole lot to be gained in terms of the quality of the pure aesthetics of seeing these deep sky studies. All right, what you're seeing right now is the settings I'm going to use in terms of picture adjust. And the one thing I did notice last night, there was a little discrepancy of shading between the top of the screen and the bottom. So what I'm going to do is I'm going to push the brightness up to 10 for the screen itself. So now hopefully the gradient that exists across the screen won't be as much of an issue. So let's start with that, and perhaps we shall play with things a little bit this evening. We'll be doing a little review of studies that we've already seen several times now. Oops, 75. And then we'll go into, probably begin with NGC 6900 this evening. So we'll save this out, and let's go have a look at Messier 22. Okay, here's our look at Messier 22. We just had a satellite passage, fairly rapid passage, probably one that's in a couple hundred miles of the Earth. As we saw last night, we calculated on the previous video that we were seeing a satellite that would probably take about 15 hours to complete an orbit around the Earth. And I estimated that it's got to be somewhere around 10 to 15,000 miles out in Earth orbit, because if it was a 24,000 mile distance satellite, it would be in geosynchronous orbit. I believe that's what they are. Anyway, so here's our view of Messier 22. We are going for aesthetics. There is a slight gradient from the top to the bottom, but not particularly distinct. So that's a fairly attractive view. I have zoomed in with the Handycam a little bit to give us a nice view of it. Remember, we're focusing on the aesthetics of the night sky with an idea of trying to get as close to what we could get through an eyepiece view as possible. Even in the eyepiece, you do see background light, especially at lower magnifications, which is why when you're doing faint galaxy studies with a telescope at the eyepiece, you try to push the magnification up a bit to dim out the background sky. So here's our view of Messier 22. Let's have a look at the Swan Nebula, Messier 17 next. Okay, here's our look at the Swan Nebula, Messier 17. I won't be giving out data tonight. We're basically just going to look at some nice images, hopefully with a nice sense of image quality. I am noticing the dark bar is a little more prevalent right now. So what I'm going to do, and I think the last time I did this, unfortunately, it upset the synchronization on the mount a little bit. So let's push this up now to 15 and see how that plays. Give it a chance to drop out. Alright. So here we have Messier 17, the Swan Nebula. I'm going to recenter it a little bit, and then we'll continue going north. We'll go to Messier 11 next. Here we have Messier 11, an open cluster in, I think it's Scutum. It looks very compact, similar to a globular, but it is actually a recent formation of a cluster within the Milky Way itself. Probably no more than 500,000 years old, as opposed to 11 or 12 billion years old that most globular clusters are. So there's our look. How about the dumbbell? Here we have Messier 27, the Dumbbell Planetary Nebula. as described in earlier videos. We're seeing this one pretty much with the axis of the poles creating the effect of an hourglass. So we're seeing it along the equatorial region of the star. And looking up data on Messier 57, I got some data on how bright the surfaces of these planetary nebular stars are. Basically, they've all exhausted their hydrogen. They're typically lower mass stars, especially when they get to the point of the planetaries. They probably have the mass of the sun, maybe twice the mass of the sun initially. They burn up their hydrogen, and at some point they become primarily made of astronomical metals, which begin with pretty much with beryllium and go more massive from there. In this case, the surface temperatures are the key to understanding them. Our own sun's surface temperature is about 6,000 degrees. These planetary nebulas have surface temperatures of about 125 to 150,000 degrees Fahrenheit. So we're talking 20 times the surface temperature, and the stars that are in their cores are basically rapidly becoming white dwarfs, and their masses are typically by this point about half the mass of the sun. They're throwing off a tremendous amount of ionized gases, and those gases are being superheated for both emission and, once they're in space, in the surrounding space, by the intense radiation pressure that these stars give off. So quite a nice view, actually, of the Dumbbell Nebula using the more aesthetic settings. And I've noticed now that we're in the sky's middle third, we're not having nearly as much of a gradient problem from the bright to the top to the bottom part of the screen. So there we have it, the middle third, giving a very fine flat view of Messier 27, the Dumbbell Planetary Nebula. Of course, here we have Messier 57, the Ring Planetary Nebula. And I did some little research, and online it said the central star is magnitude 15.75. And in doing that research online is where I discovered the intense surface photospheric temperatures of the near white dwarf stars that bring about the existence of those planetary rings and dumbbell effects. We are getting some aperture block because they're slightly south and to the west of the zenith at this point. So there's our look. We just had another satellite passage. And let's go ahead and have a look at the Crescent Nebula, NGC 6888. Okay, this is tonight's view of the Crescent Nebula, NGC 6888, an emissive reflective nebula in Cygnus, right along the axis of the constellation, by the way, the Cross. What we're looking for here is a little more definition, an extension to the nebulosity, and I am seeing it. It is extending all the way to about this point here. This is quite a good look for this faintish, low average surface brightness nebula. The star field's quite nice. I always look for these 5 stars that group together in the region of the crescent. It is visible through a 6-inch telescope. I like the aesthetics of this view. I will point out that when I got out here and allowed my eyes to dark adapt a little bit, I could tell there was a Milky Way up there, a very faint haze, but there is no way to see the Cygnus rift or anything. I'd also point out that the moon was also, once again, pretty far to the south and the west. It's not as much a factor as the lights here in John Day, accompanying especially the county fair down the road. But this is a fairly nice view. Okay, now we're going to go to NGC 6900 and see if we can run through NGC 7000 this evening. So, heading on, NGC 6900 next. All right, I'm going to give you data on NGC 6900. It's a galaxy in Aquila. Magnitude 14, 1 by 0.8 arc minutes in size. Spiral with a lowercase b, twice removed from lenticular. 230 million light years distant. At 1 arc minute in apparent size, 230. It is probably about 75,000 light years in diameter. Now looking at the screen, I am seeing the galaxy right about there. That's a pretty good look. I'd say we're seeing about half of that 1 arc minute of apparent size, which is quite good. So I think these settings are also proving to be quite acceptable when it comes to actually being able to reveal faint nebulosities. Then again, last night's seeing was not quite as good as today. There was some improvement in the smoke situation between a couple of days ago, last night, and tonight. So maybe the wildfire season is abating somewhat here in eastern Oregon. Now we're off to see another galaxy. This one's a little further north in Aquila. You can see it right here on the screen. It's got a pretty good aspect ratio. This is NGC 6901, so it didn't have far to go. Galaxy, Messier, magnitude 13.7, 1.1 by 0.4 arc minutes, so sub-oblate in presentation. It's a spiral with a bar and lowercase ab, 216 million light years distant. Puts it about the same size as NGC 6900. The view is actually quite reasonably distinct. We're now 6.5 degrees above the celestial equator. So we're definitely in the sky's middle third, and we're getting a nice look at these settings. Now one thing we might want to do is run the brightness down a little bit. I will take it down to 10, because we're going to try to stay further north now. Hopefully we won't disturb our location too much. So let's give it a chance to reset. Screen's got a little more contrast effect from top to bottom than we might like. So we know the values we want to have are probably somewhere between 10 and 15. 15 was acceptable. I might play by incrementing a couple at a time later on as we continue this evening. NGC 6905 is quite apparent on the screen. I did image it last night. I think we're getting a better view this evening, as it seems with just about everything we've looked up. It's planetary nebula in Delphinus, magnitude 12, 44 by 38 arc seconds, with a central star of magnitude 14. This planetary is 5,700 light years distant, so maybe 3 times that of the Rig Nebula. So it is a fairly nice, well-extended planetary. We're at plus 20 degrees, a really good part of the sky. So that accounts for why we're getting a pretty reasonably flat field across the imager display. We're going to have another look at another galaxy in Aquila. This was NGC 6906, magnitude 12.3, perfectly oblate, 2-to-1 aspect ratio, 1.6 by 0.8 arc minutes, spiral with a bar, lowercase bc, 219 million light years distant, puts this at about 100,000 light years in diameter. The galaxy is fairly present on the screen, as you can see, so not bad. I would expect to have a little higher contrast view at a magnitude 12.3 galaxy. I want to point out that you probably would not see a galaxy as faint as this at the eyepiece of a 6-inch telescope, even on some of the better, maybe even the best nights of viewing. And it's quite obvious that it's on the screen here. I'd say we're probably getting something equivalent to about a 12-inch view at this point. And moving on. Okay, we've imaged this the previous night, or 2 nights ago, I'm not remembering which. It's a nebula in an open cluster in Cygnus, NGC 6910, brightish, magnitude 7.4, 8 arc minutes in size with some 50 stars, the brightest of which are magnitude 9.6. It's a class 1-2. Roman numeral 1, I believe that means the stars are all pretty much the same brightness, and 2 means they're fairly reasonably compact. 3,700 light years distant. We're at plus 40 degrees. We're not getting any aperture block. We're in a very good position in the sky. The real question is there really any nebulosity associated with NGC 6910? Okay, what you're seeing here is another rather obvious open cluster. However, the last one did not have a Messier designation. This one does. This is Messier 29, also NGC 6913, open cluster in Cygnus. Magnitude 6.6, collectively 7 arc minutes in size with some 50 stars, the brightest of which are magnitude 8.6. It's a class 3-3, so therefore there's a lot of spreading out of the stars, and there is quite a diversity in their stellar magnitudes. The cluster is 3,700 light years distant. We're at plus 38.5 degrees in declination. Messier 29 in Cygnus. All right, this is another galaxy. It's NGC 6917. It's in Delphinus, the dolphin. Faintish, magnitude 14.5, 1.4 by 1 arc minutes, spiral with peculiarities, which means its morphology is a little bit unusual. 214 million light years distant puts it at about 100,000 light years in diameter. Galaxy is a little more than 8 degrees above the celestial equator. I do believe it's revealing itself right there at the tip of my finger. So quite present without much in the way of structure except the brightest core with some spreading luminosity out, especially in this direction from what I can tell. Okay, here's a real test of the limits. This is a magnitude, 6927 is not where I went. I went to A. NGC 6927A is a galaxy in Delphinus, magnitude 16.5, very small, so high surface brightness relatively, 0.3 by 0.1 arc minutes, an elliptical class 6. 27, I believe, is right there. We should be looking in this region here, and I am seeing a faint galaxy right there, but it's a little brighter than I expected, but it has that coloration that you get with galaxies. It's kind of a grayish blue coloration. I'd be surprised if we saw this. This galaxy is 193 million light years distant. It's at plus almost 10 degrees, so it's in a good part of the sky. I'll have to inspect it tomorrow. Now there's an even fainter point of light right there, and that is more likely to be a 16.5 magnitude galaxy's core. However, I would not ordinarily expect it to be able to image something as bright as faint as that. Although there it is right before our eyes. I'm going to see if there's a 27b. There is not. But there's a very excellent 6928, which is kind of edgy on galaxy, and it may actually be in the field of view. So let's hop to that. Okay, NGC 6928 is that other galaxy in Delphinus. It was just a little bit of a shift on the screen. In fact, we should be able to see both the galaxies. There may actually be a group up there. This particular galaxy, 6928, without any extension, is magnitude 12.2, 2.1 by 0.6 arc minutes. Yes, it is quite visible right there. A kind of edgy on galaxy with about a 3.5 to 1 aspect ratio. It's magnitude 12.2, 2.1 by 0.6 arc minutes, spiral with a bar, lowercase ab, and 213 million light years distant, puts it at about 120,000 light years in diameter. We're at plus almost 10 degrees in declination. What we're seeing here is a globular cluster in Delphinus. It is not a Messier, but it gives you an idea of how bright a galaxy might be and still not be seen as a comet through a 3 or 4 inch telescope. NGC 6934 is in Delphinus, magnitude 8.9, 7 arc minutes in size. It's brightest brightest stars are magnitude 13.8. It is a class 8, which means the delta between them should be somewhere around magnitude 4.5, which falls in pretty nicely here. Anyway, it is 50,000 light years distant, which puts it quite a ways out there, definitely on the very far side of the Milky Way galaxy. We're at plus 7.5 degrees in declination. A good look with some stellar resolution. Okay, if you look where the globular cluster ghost is beginning to fade out, there should be a galaxy there, NGC 6956. In Delphinus, magnitude 12.3, 2 by 1.9 arc minutes. So pretty much face-on spiral with a bar and lowercase b. 211 million light years distant, so it's about 125,000 light years in diameter, which is maybe a third larger than our own Milky Way. Its declination is 12.5 degrees, and the sky's middle third. It should be giving us a good, decent look. And I am not seeing it. So let's leave it at that. I'm going to skip around as it continues to develop. You'll like the next one. What we're seeing now is a supernova remnant, NGC 6960 in Cygnus. Its magnitude is 7, but it's quite large, 210 by 160 minutes. So its average surface brightness is going to be really faint. However, the brightest part of it are near that really bright star, which is a 4.5 magnitude 50, it's a numbered Cygni star. I can't remember the number on it, maybe 51 Cygni, I don't know, I'll have to look it up. We are getting a good view of what we would call the Western Veil nebulosity, given the name the Witch's Broom by some amateur astronomer sometime in the distant past. It's magnitude 7, as I said, 1,500 light years distant. We're at plus 30, almost 31 degrees in declination, and getting quite a fine view using these settings on this night of a 6-day moon. Okay, now we're developing another component. I believe it's the northern veil, so it's pretty faint. Actually, there's no magnitude designation here. This is NGC 6974, supernova remnant extension in Cygnus. Now that supernova extends over about 2 degrees in space, as I recall. This component is 1,500 light years distant, like the rest of it. I believe the supernova went off, or exploded, maybe it was BC. 2 to 5,000 years BC. I have to look it up. You may want to yourself. We're at plus 32 almost 32 degrees in declination with a right ascension of 2051.04. There should be some visible nebulosity on the screen. Hard to tell from my angle. Okay, not much of an adjustment in scope position here. For another part of the superveil complex, NGC 6979, supernova remnant in Cygnus, 3 by 2 arc minutes, so fairly condensed. No magnitudinal value, however. 1,500 light years distant, and we're at plus 32 degrees, so a little further north than the last study. This is obviously a very neighborly extension of the previous component of the veil complex. What we're seeing here may be the faintest magnitude Messier globular cluster. It's also in the NGC catalog as entry 6981. It's in Aquarius. We've gone fairly far south for this one. I primarily went there because it is a Messier. We're at right ascension 2053.27, declination minus 1232.14. This is Messier 72, and as I alluded to, I'm actually surprised at this. It's a little fainter than I expected to ever see a Messier globular cluster at magnitude 9.2, and about the same size as most of the faint ones. This one's 5 arc minutes, 5 minutes and 0.9 in size. The brightest stars are magnitude 14.2. If you subtract 9.2 from 14.2, you get a 5, and that's about correct. This is a class 9 globular cluster, 55,000 light years distant. We are getting some resolution for those 14.2 magnitude stars. Not a bad look, but we are getting the brightness gradient because we have tilted the scope to minus 12.5 degrees in declination. Called up this next galactic study in Delphinus, NGC 6988, because it's a magnitude and a half brighter than the faintest one we looked at tonight, but it's also twice as large. This one's magnitude 15.7 by 0.7 arc minutes, simply denominated a spiral. I do believe it's quite present on the screen right about there. It's 210 million light years distant, so it's fairly small, maybe 40,000 light years in diameter, half the size of the Milky Way, roughly. We're at right ascension 20, 55, 48, declination 10, 30, 27. We're getting pretty close to the 21st hour of right ascension. What we're going to see now is the eastern component of the Veil Nebula. This is NGC 6992 in Cygnus. Magnitude 7, it's smaller than the Witch's Room. It's 60 by 8 arc minutes. Once again, 1,500 light years distant. We're at right ascension 20, 56, 19, declination 31, 44, 36. It is quite present on the screen. It's giving a very delicious view, I think. Very, very nice, giving the conditions of the evening. Have a look at it as I continue scanning for at least a couple more studies. What I want to do is get to the 7000 series. Oh, there's a 6995 and the supernova remnant as well. Let's go there next. NGC 6995, part of the Veil complex in Cygnus, magnitude 7, 12 arc minutes in size. Should be fairly bright on the screen, and yes, it is. 1,500 light years distant, as we would expect. We're at right ascension 20, 57, 10, declination 31, 13, 06. I'll allow it to remain on the screen as I step through a few things here. Now, NGC 7000 is the North American nebula. I have never been able to image any of it. It's fairly faint and large, but let's see if we can pick up something of it tonight. That would be quite a unique observation. This is NGC 7000 Nebula in Cygnus, otherwise known as the North American Nebula. Fairly bright, magnitude 4, but also quite large, 120 by 30 arc minutes. It's an emissive type nebulosity, 1,800 light years distant. We're pretty far north, but we're getting all the aperture of the scope on it at 44 degrees 13 minutes because it is not quite culminating where it might be blocked otherwise. I have seen this particular nebulosity at the eyepiece of a 6-inch scope, but once again you have to use very low magnifications to make it out. So there is whatever view we're getting this evening. I am seeing some nebulosity up in this part here of the screen. It's probably all over the screen, it's just very difficult to make out any texture whatsoever. What we have here is probably the most distant globular cluster I have imaged. Although I probably did image this as part of the NGC 7000 to 7050 series last year. This is a magnitude 10.6, 2.8 arc minutes in size. Its brightest star is a magnitude 15.6, so we should be getting some resolution. It is a class 1, highly compact globular cluster. here's the kicker. It is 133,000 light years distant. This globular cluster is probably some 80 to 90,000 light years beyond the rim of the Milky Way galaxy. It is an intergalactic wanderer. And there's another one actually in Gemini, actually given the name intergalactic wanderer. I think it's only about 100,000 light years distant. I am very pleased that we've had a chance to revisit NGC 7006 Globular Cluster in Delphinus. Right Ascension 21, 129, Declination 16, 11, 14, and I think we will leave the evening's observations to this particular study. Carpe.